There we go. Great. Hi, everyone. My name is Nick Galbreath. Whoa, hang on here. There we go. Great. Nick Galbreath. There's Twitter. Just want to announce that I've actually formed a new company based on some of the stuff you'll be hearing, but thanks to my former employees, Ipan Web in Tokyo and Moscow and Etsy before me. These slides are also in English and in Japanese. They are online right now. So you can follow along now, or Code Blue will also post later. Excuse me. すいません。このスライドは日本語で
These slides are available. Well, these slides are not available in Japanese.
Injection attacks. It's still a #1 OWASP problem, and these are very easy problems. This is unlike what Jeff Moss said yesterday. This is not curing cancer. These are very easy problems, yet we still have a lot of problems, so we really need some other type of solution. So what is libinjection? It's a small C library to detect SQL injection from user input, such as a website or other application. It has an API in Python, PHP, Lua, and I think there's one for mRuby. And it was introduced about 2 years ago at Black Hat. Okay? Again, it's available now. It's open source. It's on GitHub for you to use right now. Why? 2 years ago, when I was looking for solutions, there just weren't very many available. The existing systems to detect SQL injection were all based on regular expressions. They didn't have any tests in terms of performance, how fast it was, were they accurate, did they work well? I actually didn't know what they were doing, and very difficult to debug. Right. Okay, so today, it's after 2 years, it's on version 3.9.1. We have over 8,000 unique sort of SQLi signatures, over 400 unit tests, and we got over 85,000 samples of actual SQL injection collected from all sorts of people, all sorts of testing applications. And right now, it's in use at a number of places. It's in mod security right now, the WAF, the Iron-B WAF, a couple of honeypots, some commercial WAFs. Kanatoko-san, who's here, I think has worked on a Java port, and there also is a .NET wrapper. So it's being used quite a bit. It's not perfect, but it's certainly a good start. So now let's talk about XSS, which is sort of the other injection. Right? In some ways, very similar to SQLi. There is no good detection system. No standard library, again, not very many tests. And again, the ones that exist are regular expression based. That is a problem due to false positives and false negatives. Great. If we look at XSS, there are really two types. There's JavaScript injection attacks, and there are HTML attacks. If you work with XSS, there's a whole bunch of different sort of names for these, but for detection, two types. Great. So first one is cross-site scripting JavaScript injection. this is your DOM style attack, right? It attacks existing JavaScript code in your application. Okay? And it's my opinion that this can really only be detected in the browser. Sometimes these attacks never even touch the server. And detecting these is really hard. HTML injection is the other type, and here the really attacks against the tokenization algorithm. Tokenization is turning text into tags. It's not a very common word. I don't know if that translates well or not. And this, the goal of this is to trick the browser into changing into JavaScript mode so you can run whatever code you want. This actually seems detectable. And here, maybe easier for me over here, these are just sort of samples. If you're familiar with cross-site scripting, these are where, where the user input gets inserted to create the injection attack. And it can be in many places. It can just be emitted right into the HTML, might be part of the tag attribute value could be inserted there, inside quoted characters, and then also only in IE, you can do back quotes as well. So HTML injection can occur in many sort of different areas. Oops. Great. OK. So a long time ago, every browser had their own algorithm to sort of turn text into tags, right? And this led to all sorts of different attacks, one for Firefox, one for IE, et cetera, because they all did it differently. However, nowadays, every current browser actually does this exactly the same way. That's great for web developers, and that's great for us, right? The HTML5 algorithm for tokenization is very specific. Okay? You don't really need to translate all this, but literally every step in the parsing algorithm is very defined. Comment start with a dash, all these different things, and that's all available for everyone to read. And inside each one, things are really clear. If it's this character, do this. If it's this character, do that. If we don't know, do something else. Really clear. And every browser now follows this algorithm. Great. So right now, for desktop browsers, around 60% use this algorithm, right? For IE, it started in version 9 upward, and all the latest versions of Chrome and Firefox have done it for a very long time. Likewise, for mobile, mobile's newer. Over 90% are HTML5. That's great news. So, oops, excuse me. The rest of them, the rest of the troublemakers, are IE6, IE7, and IE8. IE6 someday will die, hopefully, right? It has to. IE7 really tiny, so don't worry about that. IE8 is a bit of a problem. It's still used a good bit, 20%. Mostly, however, on Windows XP. So we're hoping that usage of Windows XP goes down. I'm not convinced we should focus our energy on protecting users on Windows XP. I'm not sure you can do it anymore. So, given this, I'm going to introduce libinjection XSS. And one problem I saw in old systems of detecting cross-site scripting is they weren't focused. So, or they didn't have a clear goal. My goal is to detect HTML injection attacks on new browsers. I do not care about XML, XSLT injection. Different problem, important, but different problem. I don't care about IE6. And DOM-style attacks are just different. And there's a lot of good innovation in protecting the client. Chrome and IE both have interesting systems, but not today. Libinjection has a complete HTML5 tokenizer. Unlike a browser, it does not try and build a tree or a DOM or anything like that. It just tries to emit token events, and I'll show what that is in a moment. Also, no copying of data, very, very fast. Okay, so here's a sample of what sort of the output of this tokenization step looks like. You know, up top you have sort of just a tag that comes in, and out comes these little things like this. You know, and I think if you've worked with HTML, you'll understand this. It just sort of emits all the different pieces of the input. Now, most user input, if it's not HTML at all, like just from your web page or website, please enter your name. Most of the time, it's going to emit nothing, just one big blob, because it's not actually HTML, right? So I'm going to take user input, run it through the tokenizer 6 different times, because that's how user input can be injected in HTML pages, right? Whoops, there we go. And then when I have this list of tokens, I can actually ban things that look bad. And obviously things that are script tags coming in, you just want to ban those right away. I found enough problems with anything XML-like or SVG-like just to recommend banning those elements too. The classic sort of like on, star, the attributes for JavaScript, the on blank things, ban those. URLs that are JavaScript, ban those too. And the idea is this is much less false positive because you're using the structure of HTML to detect things. Like on error by itself won't be banned. It has to be part of a tag and a system to work. Okay, so write the algorithm. How do I show that it works or doesn't work? So training data. Okay. First thing I looked at is XSS cheat sheets, which there are a number of. Unfortunately, the few that I found are very old. They haven't been updated. As sad to say, some just don't work anymore. So I removed all the old ones that were kind of junk. Let's see. Then, yeah, so get rid of all the old ones. Keep only the ones that actually still work. If you're not familiar with html5sec.org, it's a really good website. It lists every type of XSS vulnerability and lists what browser it's for. So it's a very good resource, but also has a lot of very old exploits. Great for history, not so good for training. This gentleman, whose Twitter handle I cannot pronounce, he regularly produces really good XSS that I've never seen before, very regularly. And he's published a few documents on XSS that are really great resources. So I've integrated his work as well. Oops, whoops, whoops. Sorry there. And then I took one attack scanner, something you'd point at a website to find vulnerabilities, and took its output to see how it tests for cross-site scripting, and captured that and put it in our test suite. The mod security team also gave me part of the Shazzer database, fuzz database, also a very interesting resource. It tries to find bugs in the HTML parsing algorithm. It's worth looking at if you have a moment. Okay, so what's the current status here? Well, first, it's available now. It's on GitHub again. I didn't mention it before, but the homepage or website of libinjection is here. It's in the main line. You can use this right now. It is early, though. I did run it through, so I collected all these sources, and I got about 1,600 unique XSS samples. And I run it through, and I get almost everyone detected, and I got 11 ones it's not detecting. And I'm very pleased to say that these only are for one particular problem, which I am researching now on how to fix. Unbalanced quotes, hard to say in Japanese. My friend couldn't quite figure it out. Incorrectly formed HTML attributes, where they have different quote characters inside each other. IE processes them very differently, and I'm working on fixing that. Okay. So parsing all this work and doing it 6 times sounds slow. The good news is it's not. For most inputs, very little work is actually done. And on my laptop, I'm getting over 500,000 checks per second. So it's definitely fast enough. You won't even notice this, if you integrate this into your website. The other thing is the algorithm is actually pretty simple. The source code is in C, but if you are talented in programming, I think you could port it directly to another language, and it would still be very fast. Hey, okay, so what's left? It's still early. My experience before says, because it's early, there will be incredible failures or bypasses you will find. I'm still working on that, though. I need to run it through normal input to make sure false positives don't happen. If a website using this code has lots of false positives, they solve that problem by turning it off. I need to put a test bed or a place where you can go on the web and enter your own input to test against. I need to publish code coverage and QA tests. And I need to add scripting languages. But this should be done in the next couple weeks. So if you have XSS sources or if you love XSS, please contact me. I'm always looking for new sources of information, and I'd love for you to try out libinjection XSS. As a final note, these photos, I was in California 2 weeks ago, so this is Death Valley. Anyway, thank you, Code Blue, for your time. I hope to see you soon. Thanks.